Okay, the goal here is just to do some ordinal data. Now, you can't just use the simple LM function. Regression analysis has different types of dependent independent variables. So here we're going to see a dependent variable that is by ranking. Now, with ordinal data, you don't know the exact space between the ranks, like many people might have a different opinion on strongly disagree, or rank this 1 through 5. But it's very, very important to understand that this ordinal data has its own stuff. So we're going to use the ordinal package. It's already there, but you know how to get the ordinal package out, or any package install in quotes and then library no quotes. So we're using the ordinal package. See that P package. And the function, as I'm dying, is CLM. So it's like the LM function, just CLM. See? Ordinal package. So after you get the ordinal package out, as we just saw, right? Ordinal, what we're going to do is now there is a default data set called wine. So we're going to view capital V wine. There it is. Very easy to get wine. All right. Now we have to attach it. Oops. I didn't know attach had two T's. So you go and attach it. All right, now we're going to do a simple ordinal regression on what? Well, let's take temperature. Temperature of the wine. Sorry if you people don't drink. I'm an alcoholic. And then response. No, I'm sorry, rating. So you have a 1 to 5 rating, whether they like it, no, 1, 5, the highest. And does the temperature of the wine, we'll just use it simple, have an influence on the rating? So we'll just call it tasty. And then CLM, the regular CLM function. And then we'll just do, okay, what's the independent dependent variable? The dependent variable is the rating itself, right? Tia tilde. So we're not doing anything different from, LM, GLM, even ANOVA, etc. It's kind of the same logic, rating, temperature. And then I always put the data set on because remember, if you follow my videos or in my class, we did ice cream and that had a temp for temperature. So you want to make sure you get the data so our studio kind of understands what's going on. So now we do tasty, summary of tasty. Oh, I had a tasty 2, tasty 3 because I was fooling around with the data. So now you could take a look at this data set really quick. 72 points. That's pretty good piece of data. And now we can easily, right, interpret the results. So it's basically saying this is the independent variable. Temperature warm seems to be significantly higher when it's warm, the rating, with a very low standard error, very high Z value, 4.4. And obviously, this is the p value, if you've been following my classes, below 0.05. So the log odds there, our practical value is 2.2. That is, it seems to be going up significantly by at least 2 points every time that it gets warmer. Or warm, I shouldn't say that, because whether it's warm or cold, because we're doing log odds, it's not like temperature in ice cream where, as the temperature goes up, the consumption of ice cream goes up. It's a little different. This is the log odds without getting bogged down in that. The standard error, anything with the word residual error, the lower, the better for your data. The standard error is basically if we did repeated samples, how close are we to the real mean and standard deviation of the distribution of data. Here we have the z value, right? And that gives us our p value, like the t value, but the z value assumes that we know the mean and standard deviation of the population. Remember, this is a sample of the population, that data set right up here. So what this is saying essentially is that it is statistically significant. There is a relationship between the temperature of the wine and whether people like it on a 1.5 scale. So here we would reject the null hypothesis that there is no relationship and would conclude with an alternative hypothesis that warm does increase people's liking, I guess, of this wine. But what's interesting down here, these are threshold coefficients where they become significant. And you see the t-value is pretty good. But look at this. 1 and 2 seems to be the opposite direction for some reason. And all the others, 2, 3, 3, 4, 4, 5, are all going up in the warm value. So that's pretty interesting. So what the threshold coefficients are telling us, which ones are essentially significant. And it is significant, but in the opposite way for 1, 2. That would be an interesting data set to explore. But regardless, I just wanted to go over simple ordinal regression. Ordinal regression, as we just saw, is a rating. And I like that that word says rating. You have 1, 2, 3, 4, and 5. Temperature, we're using as the independent variable, whether it's cold or warm. And that makes it just easy to get your hands kind of and get your mind around ordinal regression. Because it's ordinal, there is a ranking. LM is not the proper function. What is the proper function is clearly the CLM. There's also POLR. That comes from another package, which is also a good function to test ordinal data. That, however, doesn't have a p-value, and I think students do, unless you're a real diehard Bayesianist, feel comfortable with the p-value in order to interpret the results at this stage. So thanks everyone for coming out, and I hope you understand ordinal ranking data better. Take care, everyone.